So your sum here is number 8. Given y is equal to x to the power of x, you need to prove that d2y dx2 minus 1 by y dy dx whole square minus y by x is equal to 0. So our first duty is to find out dy dx. So we start with y is equal to x to the power of x. Okay. How do you differentiate this? You take log on both sides. You have done this kind of differentiation earlier.
Yes, sir.
Yes, sir.
Okay. So you get log y is equal to x log x. Now differentiating both sides. With respect to x. This is a very important function actually. Y is equal to x to the power of x. You must know the differentiation of this. In maximum minimum also we will come across this function. So you get log y is 1 by y dy dx, isn't it? Different ddx of log y, and x log x you differentiate by u into v rule, which is x ddx of log x, which is 1 by x, plus log x ddx of x, which is 1, right? Can I do it directly?
Yes, sir.
Or should I write ddx?
So you can do it directly.
Okay.
Yes, sir. Directly.
Okay. So that means you get 1 by y dy dx is equal to 1 plus log x. Okay. That means dy dx you get as y into 1 plus log x. You can put the value of y, but let's keep it as it is. If required, we'll put the value later. Okay. So let us call this 1. Now again, in order to find d2y dx2, we have to differentiate both sides of 1. So therefore, d2y dx2 is equal to ddx of dy dx, which is ddx of y into 1 plus log x. Okay, which is y ddx 1 plus log x plus 1 plus log x. ddx of y means dy dx. Okay, so now simplify. ddx of 1 plus log x is 1 by x simply, and you have 1 plus log x. And what is the value of dy dx here? In 1, you put that value, y into 1 plus log x, right? This is the value you have, isn't it? So what you get here is y by x. We are not putting the value of y only. Others are we are all putting. Okay. If required, we'll put the value of log y of y. Okay. So y 1 plus log x whole square, which is y. You can take common. What are you left with? 1 by x plus 1 plus log x whole square. Fine. So this is what we get d2y dx2. And what are we required to prove? d2y dx2 minus 1 by y dy dx full square minus y by. So let us put it on the left hand side. So let's see. Left hand side. Left hand side is d2y dx2 minus 1 by y dy dx whole square minus y by x. Okay, now put the values. d2y dx2 we have found as y 1 by x minus 1 plus log x whole square. minus 1 by y. Now dy dx. What is dy dx here? From 1, y into 1 plus log x. Y into 1 plus log x whole square. Okay. Minus y by x. So now we simplify this. We get y by x minus y into 1 plus log x whole square minus 1 by y. Here you get y square into 1 plus log x whole square minus y by x. So what you see here is that this plus y by x and this minus y by x, they cancel. So what are you left with? Minus y into 1 plus log x whole square. And this y again cancels with 1 y in the numerator. You are left with a minus y into 1 plus log x whole square. Now I doubt whether this will be a minus sign. Okay, this should be a plus sign. You understood what I'm saying?
Yes, sir.
Why should it be
Yes,
a
sir.
minus? Why should it be a plus sign? Tell me, why should it be a plus sign? This sign, why should it be a plus sign? Because if this is a plus sign, this is a plus sign, then this is a plus sign, then this is a plus sign, then this will be a plus. Only then you will get 0. Understood?
Yes,
Because
sir.
this and this will cancel. Is that absolutely clear?
Yes, sir.
Govinda.
Yes, sir. Yes, sir. Yes, sir.
So I think, not think, in fact, I am very sure that this will be a plus sign. That's a printing error there. Okay. Because our differentiation is correct, absolutely. There's nothing wrong with our differentiation. In differentiation, you will not get a minus sign here in this. In y is equal to x to the power of x, you will not get a minus sign in any differentiation, neither in dy dx nor d2y dx2. Okay, so fine. So we can proceed with the next one. What I intend to do next is number 10. Number 10. Given here, y is equal to tan inverse x whole square. Okay, you need to prove that. You need to prove that x square plus 1 whole square into d2y dx2 plus 2x into x square plus 1 dy dx is equal to 2. This looks like a little complicated expression, but it is nothing. There is nothing complicated. We simply find dy dx and d2y dx2. So we have y is equal to tan inverse x square. Therefore, what is dy dx? Dy dx, we first differentiate the power to get 2 tan inverse x into the differentiation of tan inverse x. So we get 2 tan inverse x divided by 1 plus x square, right?
Yes,
Yes,
sir.
sir.
Okay. So now once we get 2 tan inverse x by 1 plus x square, okay, what you do here is you see x square plus 1 whole square. You square both sides. Okay, no need to do that debate that way. That was science student actually. For commerce students, I think this way is better. You find dy dx and you find d2y dx2. Therefore, d2y dx2 is ddx of. Otherwise, the way that I was going to show you, that was a very easier way. That your calculation would have been much reduced. I showed Amir yesterday one way. Did you see that method?
Yes, sir.
No,
Govinda,
sir.
did you
I
see
have
that?
downloaded. No, sir. I have downloaded.
Okay.
Today I will
That
see.
is a science method. I mean, mostly science students are required to know that method. 2 ddx of tan inverse x by 1 plus x square. We differentiate this by u by v rule. Okay. Twice u by v is 1 plus x square and ddx tan inverse x. What is ddx tan inverse x? 1 by 1 plus x square minus tan inverse x into ddx 1 plus x square. What is ddx 1 plus x square?
Sir, 2x.
2x divided by 1 plus x square whole square. Okay. So here 1 plus x square,
Yes,
1
sir.
plus x square cancels. You are simply left with twice 1 minus 2x tan inverse x divided by 1
1
plus x
plus
square
x square whole
whole
square.
square. Okay. Um,
Yes, sir.
Now we shall start working from here because we know dy dx and d2y dx2. We'll put it on the left hand side. LHS. Let's see what is our LHS. X square plus 1 whole square d2y dx2. Next, plus 2x into x square plus 1 dy dx. This is our left hand side, right? Now we put the value simply x square plus 1 whole square and d2y dx2 we have got as twice 1 minus 2x tan inverse x by 1 plus x square whole square, okay, plus 2x into x square plus 1 and dy dx here is 2 tan inverse x by 1 plus x square. 2 tan inverse x by 1 plus x square, isn't it? We simply put the values
Yes,
of dy
sir.
dx and d2y dx2. So see here, these two cancel. Also here, these two cancel. So what are you left with? You are left with twice 1 minus 2x tan inverse x plus 4x tan inverse x. Now you multiply with 2 everything and open the brackets. You get 2 minus 4x tan inverse x plus 4x tan inverse x. Okay, so what happens? These two cancel. Simply get 2 is equal to RHS. Proved. Clear?
Yes, sir.
So this is what. And the next one that we
Yes,
are
sir.
going to do here is number 15. Okay, and give you one idea of one parametric function and then we'll finish off this class. I'll continue. Most of the work has to be done on Friday because you need to know, you need to just, before coming to class tomorrow, You just need to see differentiation, how to find d2y dx2 for parametric functions. Okay, so I'll finish one problem, and then after this one more, and then finish. So given y is equal to a cos log x plus b sin log x. This is number 15. B sin log x. Okay, to prove, you have to prove x squared d2y dx2, x squared d2y dx2 plus x dy dx plus y is equal to 0. Okay, so we start with y.
Okay.
So we have y is equal to a cos log x plus b sin log x. Okay, so therefore what is dy dx? Dy dx is a d dx cos log x plus b d dx sin log x. Okay, so now here this is a. How do you differentiate cos log x? You first differentiate cos to get minus sine, and then you differentiate log x to get 1 by x plus b. Again, first you differentiate sine to get cos log x. Okay, and
Yes,
then
sir.
you differentiate log x to get 1 by x. Okay, so what you get here is minus a sine log x by x plus b cos log x by x. Okay, this is what you get. Now see here, the point that I'm trying to make here is that if I differentiate this expression once again, okay, I have x in the denominator. Unnecessarily, I will have to use u by v rule. You can do it that way. Okay, you can find d2y dx2 uh, by your u by v rule for this also, no problem. But see, the point here is that just because of an x, I will have to use a u by v rule. Okay, and using u by v rule is not an easy job, let me tell you. Okay, because you have to remember the formula, chances of making mistakes are higher because of signs. So what you do here is you get, since you have x in the denominator, okay, what you can write this as, you can write this expression as minus a sine log x. You can take the LCM actually, plus b cos log x whole divided by x. Okay, now what you do here is you multiply both sides by x. So what do you get? You get x dy dx. Just because I want to remove x from the denominator, you get b cos log x. I'm just writing the positive sign first, minus a sine log x. Can I write it this way?
Yes, sir.
Yes, sir.
Just because I want to remove x from the denominator. Okay. So now what I do is I differentiate these both sides again, and we'll do by implicit function. So to find d2y dx2 by implicit function, differentiating both sides with respect to x, we get first x, you differentiate the left hand side by u into v rule. This is your u, this is your v. X d dx of dy dx plus dy dx into d dx of x,
Which is one.
right, which is 1, is equal to,
Yes, sir.
now you differentiate this, you get b ddx cos log x minus a ddx sin log x. Sin log x. Okay. Okay. So now what do we get here? We get x ddx of dy dx is d2y dx2. Okay. Plus dy dx of x is 1. So simply get dy dx, right, is equal to, now you differentiate the right hand side. B ddx of cos log x is what? Minus sin log x into ddx of log x, which is 1 by x, right? Minus a, what is the ddx of sin log x? It is cos log x divided by the ddx of log x. Okay. So now see what we get here. We get x d2y dx2. No need to put the value of dy dx here. You will get the result directly, in fact. X d2y dx2 plus dy dx is equal to, okay, you take the LCM here, you get minus b sine log x minus a cos log x whole divided by x. In the next step, you will write the left hand side as it is. You see here, what do you have to prove? X square. See, you've already got on the left hand side, you already got an x d2y dx2. You write the left hand side as it is. Now what you do here, on the right hand side, in the numerator, you take minus common. Divided by x. Now you see, minus b, this is a b sine log x plus a cos log x. This is what? This is our, we are getting y back, isn't it?
Yes, sir.
In the numerator. So we put y. That means x d2y dx2 plus dy dx square is equal to minus y by x, right? Now you multiply both sides by x. You get x square d2y dx2 plus x dy dx square, not square, this is not square. Why have I written square here? Minus x dy dx is equal to minus y. So therefore, you have x square d2y dx2 plus x dy dx plus y is equal to 0, which is our required proof. Check. This is our required proof, right?
Yes, sir.
So what you observe in this
Yes,
problem
sir.
here is that instead of putting the value of dy dx, sometimes it works. So if you you get used to this technique, this is a better way of finding the uh, second derivative. Otherwise, see, once I have found dy dx here, okay, once I have found dy dx in this step, or maybe this step, yes, this step, this one. Once I have found dy dx here, if I differentiate this by u by v rule, this is going to get very, very complicated. Okay, because you have sin log x in the numerator, you have x, and then the formula of u by v is also very complicated. So what I do is I remove this x. How do I remove this x? By multiplying dy dx by x, and then I differentiate once again. So later when I am required, then I will put the value of y and I'll put the value of dy dx. So what I see here is I don't even require to put the value of dy dx and y. I'm getting the result directly. Understood? So not all sums can be done by finding dy dx and d2y dx2 separately. Okay, so these are certain exceptions. Just remember these exceptions. Now 14.1 I'm going to do. You can try out number 14. Not 14. Yes, number 14 you can try out. Number 14. Okay. A e to the power of mx plus b e to the power of minus mx. This is very similar to number 15. Clear?
Yes, sir.
I'll do number 16.
Yes, sir.
How to find d2y dx2 for parametric functions.
Okay, sir.
Just one problem I'll show you, and tomorrow before coming, you just do a little bit of revision of this, and then you come so that it is easier for me to kickstart the class. Okay, so this is let us look at 16 part 2. Okay, given here x is equal to 80 square and y equal to 280. Okay, you have to find dy dx first from here. Okay, so you do that as you do your parametric functions. Okay, so therefore what do you get? Dx dt is equal to 280, right? And what is dy dt? 2a. Okay, so therefore what is dy dx? Dy dx is dy dt by dx dt. You remember all this or not?
Yes, sir.
2a by
Yes, sir.
2a. The 2a cancels, you simply get 1 by t. So you're getting dy dx as 1 by t. Now the point is how to find d2y dx2. Remember this and listen to this very, very carefully. d2y dx2, you write this as ddx of dy dx. Why you should be careful? You should be careful because dy dx here is in terms of t. It is not
1
in
by
terms
2.
of x and y. Okay, that is why you need to be a little careful. What you do here is remember this technique. ddx of you write dy dx as 1 by t. Now see here, you first differentiate 1 by t with respect to t. Okay, you have x here, doesn't matter. You first differentiate it with respect to t. So you get minus 1 by t square. Right or wrong?
Yes, sir.
Govinda, right or wrong?
Yes, sir.
You get first differentiate with respect to t. Okay, and
Yes,
then
sir.
what you do is, since you have differentiated with respect to t, after differentiation with respect to t, you multiply this with dt dx. Understood?
Yes, sir.
This is very, very much like your chain rules. Remember chain rules I told you?
Yes,
Yes,
sir.
sir.
Yes,
This
sir.
is very similar to that. So when you are finding ddx of 1 by t, you first differentiate it with respect to t and then multiply it by dt dx. Okay. So you get minus 1 by t square. And what about dt dx? I can write this as 1 by dx dt, right? Minus
Yes,
1 by t square. And what is dx dt here? 280. So this is into 1 by 2a t. So you effectively get minus 1 by 2a t cube. Clear with this?
yes, sir.
This is how you find d2y dx2 for parametric
Yes.
functions. So I stop here for today.